Okay. Yeah. Hi everyone. Good afternoon. Today I'm Zhihao from University of Alberta in Canada, and we have a commercial partner. Oh, what happened? We have a commercial partner, Xinming Technology. Today I would introduce our work, annotation-free online adaptation for sensor-based hand signal recognition in crane operations. In construction site, the crane operation is heavily relying on the signal man. Since the operator should follow the instruction from the signal man all the time. And so it's very important to build a reliable and easy way for their communication. And the industry have their solution. They use multiple signal mans or two-way radios, but the statistics indicate there are over 100 crane accidents per year and 78 fatalities per year, and 9 of it are directly caused by the communication failure. And the current academic attention are mainly focused on improving the recognized accuracy. However, the real construction constraints introduce the most challenging part. For example, when we want to recognize the hand gesture, we need lots of data from sensor, and we need labeling these data. It's time consuming and always require extra labor to do it, which is also costing. And in the worldwide view, we have a different hand gesture standards, like UK and the difference in this case is UK and Canadian standards. They share UK and the Canadian standards. They share the 16 hand gestures, while UK has 4 unique gestures. So what we want to achieve in this project is we already have a trained model which can recognize Canadian gestures very well, but how we applied this model to the UK gestures without annotation and cost us too much. And these slides show our frameworks. First, we continuously collect the unlabeled data during the daily use. We have already passed our device to a UK signal man, and the UK signal man just work as usual. Then our system keep collecting data, and we use these unlabeled data to discover new gesture clusters, and these clusters represent the potential new gestures, which are different from our Canadian data. And the third, we perform a weekly supervised adaptation. Since we have already know there is 4 gestures are different between these 2 standards, so we cannot say it's a totally like an automatic process. We say it's a weekly supervised adaptation. We first expand our deep learning module, which we used for Canadian gestures, and to make it support more gestures are coming. And in this kind of tasks, the main challenge is when we introduce the new gestures, the model will more rely on or more want to predict the knowledge he newly learned. This is the key challenge. So to solve this, we use knowledge distillation, and this allows the model to learn new gestures while maintaining the knowledge of the existing Canadian gestures, so they will not forget. So then finally, for the inference, we use the dual model strategy. Also, the original model, the baseline model for Canadians, provide reliable prediction for the for the old gestures, and the new model, adapted model, which can recognize the newly learned gestures. So they work together to improve the robustness and reduce forgetting. And to achieve this, we both developed sensing hardware and software platform, which for data management and online adaptation. First, we developed this cloud-based variable devices. We have a accelerator, gyroscope, and we also placed 3 flex sensors in the thumb, middle finger, and the index finger. They are for capturing the hand gesture, also movement. And for the mobile application, this is for uploading the data during the use. Also, it's for display what is happening, what the gesture is from the signal man. We displayed this to the operator. And for the method, this is the whole part of this. This is the key part of key components of our research. On the left, on the left is the new gesture discovery stage. After the deployment, we continuously collecting the unlabeled data, and we then extract the features and into the potential gesture clusters. And this finger visualized these clusters. As you can see, there is 4 new introduced clusters, which are different, and which are different with the existing gesture clusters. And the right ones that show the learning stage. The newly introduced cluster with pseudo labels are mixed with the old labeled data, which are our Canadian labels, the shared 16 known gestures, and they are mixed to put it, send it to like a normal deep learning model. I'm not sure how well you guys know this, but in this project, we are using a CNN long short-term memory hybrid network to learn the gesture features. And to forget or to reduce the forgetting, we use the knowledge distillation, which we have a frozen baseline model, which are used for training the Canadian gestures. We use it here as a teacher, and they can help the adapted model to learn the new gestures, while the new model can refer the old decisions, so they will not forget the Canadian old gestures. Then both works together, to help this model learn what this UK gestures is. And actually, it's a very challenging project for reducing forgetting. So we have another method, another strategy. These things happened on the inference strategies, which is dual model inference. Like after finish the training, we deployed it to our devices. When the signal man using it, the new sensor data generated and sent it to our app. Then they ask which gesture is. We use this process to deal with. First, if the adapted model predict this is the newly gestures with very high confidence, we just accept it. Otherwise, if the new model said probably this one gesture without so high confidence, while the baseline model said no, this is the old gesture with high confidence, we will roll back to our baseline model. Then they work together to generate all the hand gestures, both new and old. And yeah, for the result, for the whole system we need at least two performance indicators. The first one is how well we learn the new gestures, which on the confusion matrix, and overall performance. So the right side, all gestures per class performance, which is about 89%. For the newly introduced gesture, our recognized accuracy is about 95. So yeah, they work together to achieve the very high accuracy, also reduce the forgetting. And in summary, in this proposed work, we achieved the reliable adaptation to new gestures, and we maintained the stable performance of the previous gestures without any labeling job, without any annotation job required. Yeah, and we believe that the application with AI in construction is not only an offline trained model. It's we should make the model have the ability to keep learning in real construction site. That's it. Thank you.
Questions? Extracting training data from larger model to train a smaller model, like ChatGPT, generate the training data to train DeepSeek or Llama.
Yeah.
And but for your case,